Hello, students. We have a new booklet, and this is after we have gone through everything. Um, when solving any word problems, this is page 3. This is day 6, or I'm sorry, not day 6, day 7. Right. Really starting to work on solving word problems and using equations to solve problems, even though you may not need an equation to solve them. But you have to keep in mind that we keep telling you that eventually you're going to have to use algebra, so we have to show you how to do it on easy problems. When solving a word problem, this is the key. It is very important to remember the math attack. Okay? Just as a review, I have all 5 steps of the math attack. You read, you get the gist. What are you trying to find? You reread again so that you can get all the important information. Okay? Sometimes problems are done incorrectly because of lack of reading or rereading. Provide a visual representation. We'll use an equation to do that for some of these problems. Some of them we may draw pictures. Show your work to solve, and this is probably the most important thing. When you're done, does your answer make sense? Okay? Verify. Okay, so we're using equations to solve problems, and we're going to, for right now, I want to skip this part. And on page 4, exercise number 1, for the time being, because I may come back to them a little later on, and I really want to focus on the types of problems that are more realistic, like real-world type problems. Okay, here's something that's very important at the bottom of page 4. When you're solving problems using algebra, it's important to remember this. The algebra must flow from what happens to the numbers, not the other way around. And I think a lot of times where students have trouble in algebra is that they're not understanding what's going on in the problem mathematically. You need to understand the math of the problem. All right? That was the purpose of doing that opening exercise with the problems that didn't have numbers in them. Because if you don't understand the math behind what's going on, then you can't solve the problem, or you cannot use algebra or set up an algebraic equation. All right, so here's example number 2. And I'm going to do example number 2. I'm going to do example number 3 on the next page, and example number 4. All right, those are the 3 that I'm going to model in this video. Hopefully I can get it done in the next few minutes. And then, from there, there are some exercises, and there's just a ton of problems in this lesson for you to work through. All right, so let's get started. Example 2. Sally designs web pages for her customers as a way to make money. She charges $135.50 per web page. However, she must pay a monthly rental fee of $650 to rent her office space. All right, so I'm going to reread this to annotate here. $3 per web page, that's important. And pay a rental fee of $650. All right. Now, I'm going to do these 2 problems backwards because in order to write an expression, which is an algebra using a letter, you have to understand what's going on. So we're going to assume if Sally designed 5 web pages last month, what was her take-home pay after expenses? So take-home is what you actually bring in. So you bring in money, and then you pay money out. The take-home is what's yours. All right? That's kind of what they call net pay, like on a paycheck, if you ask your parents or grandparents or whoever about, paychecks. So Sally's going to design 5 web pages. $135.50 per web page. So it's $135.50 times 5, which I'll save you a little bit of math, is $677.50. Okay? Now, she has to pay a rental fee. She has to pay rent. So that rent would get subtracted from what she made. So she's going to make $27.50. That's what she brings home. So that's not much for a month. So that means she's going to need to make a lot more. She's going to need to make way more web pages. Right, now, here's how the algebra leads into this. We're going to pick a variable and make a let statement. We're going to let W equal web pages. Right? So what's going to happen is you take the $135.50 and you multiply it times the number of web pages, W. And then from that, you need to subtract the $650. So now this is an expression that represents her take-home pay. It's $135.50 per web page minus the $650. Some of this is going to seem familiar because we did touch upon this back in Module 2. Right. And that would be done for this one. All right. Example number 3. So what I'm probably going to end up doing is I'm going to set the equations up, and then you can solve the equations because we've already practiced that skill. So the concept here is going to be setting up that equation. Example number 3. Mrs. Hurd bought 3 pairs of jeans and 1 top that cost $15. Cost a total of $150 before tax was added. What was the cost of each sweater? Actually, it shouldn't be sweater. It should be each pair of jeans. That's a typo on my part. I'm also going to show you how we could use a tape diagram for this. Here's a tape diagram model of the scenario. No, that is not the bell that ends class for you. Okay. I'm going to make 3, okay? Because each box, I'm going to represent a pair of jeans. So I'll put J's in there. So we have 3 pairs of jeans. And in addition to that, there's $15 to represent the 1 top that costs $15. Right? Now, all of this together equals $150. Your job would be to figure out how much each pair of jeans would cost. Right? So now we can use this tape diagram to write an equation. We're going to let J equal jeans. Right? So then you would have 3 pairs of jeans. 1, 2, 3, count them together. Plus the $15 will equal the $150. All right. You can solve this equation on your own, and I'll check that. All right. So from here on out, it's pretty smooth sailing. What the pair of jeans would equal. You can do that on your own. The big key is getting this up. This is the important thing right now, setting the equation up. Then solving it's the easy part. All right, example number 4, last one. Here's more of a realistic type problem. To rent a car, the ABC company charges $75 a day plus 5 cents a mile. How many miles did Mrs. Hadley drive if the cost of renting a car was $92.40? We're going to write an equation to represent the scenario. We're going to so what's the gist? The gist is, what are we trying to find? We're trying to find how many miles. So I'm going to let M equal the number of miles. Now, what's happening mathematically? Well, the ABC company charges $75 a day. So you're going to start with the $75 plus, makes sense, 5 cents per mile. And we write that by 0.05 times M. Total is $92.40. Okay. Now, you can use a calculator to solve this. And when you solve this equation in real life, you're going to have a calculator that's be able to use. All right? 75 plus 0.05 M is equal to 92.40. And you can, like I said, once again, you can solve that. I think that's going to be the easy part, especially when you have a calculator. Right? So then your job would be to continue working through these exercises, and I'll just check in with me, and I'll let you know what you need to be doing. So.